guys. Hope you are well. Today we have got the GCSE Combined Science Trilogy, Paper 2 for Physics, higher tier, from June 2021, if you do want to work through it. We've got the equation sheet on the laptop, and we're ready to go. We'll read through all of this in a couple of minutes, and we'll be starting in 5 minutes. Time, so if you are here and you're new around here, this is what I'm going to... sorry about that, guys. So if you're around here, this is what I'm going to be doing every so often. Instead of studying these things, I'm actually going to be going through past papers. So there's 2 different ways that I'm going to be doing it. Either I'm going to be doing it for like this, so I'll be teaching it as I go, like talking through the questions, telling you, or I will actually just do it with you guys and just do it myself, kind of thing. Why have I turned the filter on? No. Right, hang on. Let's just make sure I can do what I want to do. It feels like I've put something on. Hang on. It looks like I've put a filter on. I genuinely didn't. Oh. Okay, well. That's kind of dampened the mood. I can't see chat, by the way. I'm just going to pull up the chat on my laptop, because I cannot see it for some reason. It is not showing it. Right, well that ain't me, is it? Bloody hell. I also don't know what YouTube channel I'm streaming on, so this could be very bad. Okay, I am streaming on the channel I thought I was streaming on. Oh, well, chat's disabled. For God's sake. Hang on, let me re-enable chat, so maybe that's why I can't see. What? Is the chat available now? Okay, does the chat work now? Let's have a little look. Let me know if the chat's working. Oh, I keep knocking. Yeah, the chat's working now. Let's see if I can see it on the screen when a message comes through. No. Right. It's where I can see the chat here, but I thought it'd come up on the the phone that I'm streaming from, because I'm actually streaming through YouTube today. So I hope it works well. Hello, Lucky. Welcome in. I'm not doing it through StreamYard, because on StreamYard, I know how everything works. But they recently allowed anyone to stream via YouTube, because before you needed 600 subs. Oh, I keep doing it. Recently, you needed 600 subs, but now it's changed. Anyway, we're going to be doing the June 2021 paper. I've got the physics equation sheet and the chat, so if you want to answer questions with me. Anyway, it's a 1 hour, 15-minute paper, so we're going to be doing about 1 hour and 30, I think this will take. So I'll read through all the questions, and then I'll work the answers through as well. We've got a mark scheme at the back, which we'll go through after each question, not each sub-question, each question. So there's 6 total questions, but then each, like, you get 1.1, 1.2, 1.3, etc. So I'm going to read this stuff on the front here. So materials, if you're doing this paper along with me, it's June 2021. You need a protractor, ruler, a calculator, and the equation sheet. Instructions, you need to use black ink or a black ballpoint pen. Pencil should only be used for drawing. Fill in the boxes at the top of this page. Obviously, I don't need to do a centre number or candidate number. For the real thing, you will. If you need extra space for your answers, use the line pages at the end. I don't have that, so I'll just get my notebook out on the side here. Write the question number against your answers. Do all rough work in this book. Cross through any work you don't want to be marked. In all calculations, show clearly how you work out your answer. Maximum mark is 70. Mark for each question is shown in brackets. You are expected to use a calculator where appropriate, and reminded of the need of good English and clear presentation in your answers. So let's get started with the first question here. Question 1. Figure 1 shows a stretched spring. The spring is elastically deformed. What is meant by elastically deformed? Tick 1 box for 1 mark. Is it as the force on the spring increases, the length of the spring increases? B, only a very small force is needed to stretch the spring? C, the force on the spring causes it to change shape? Or D, the spring will return to its original length when the force is removed? Write in the chat A, B, C, or D with your answer. I think I know it. I'm not sure, though. Thank you for the likes, whoever that is. Thank you for the likes. Okay. Let's go for... I think it's D, to be perfectly honest with you. So we're just going to tick that box there. Next. Describe a method to determine the extension of the spring. Hang on. Let me just angle the camera properly and hope it doesn't fall over. It's going to fall over. Brilliant, of course it is. It's just so I can actually, so you can actually read the question. There we go. Right. Describe a method to determine the extension of the spring. I don't fucking know. Correct answer. Measure the length of the original spring and extended spring, and then do extended spring minus original spring. Next. The extension of the spring Why is this so bad? Hang on. Why is this so bad? Like, the text, you can hardly read it. The extension of the spring is 80 millimeters. The spring constant is 40 newtons per meter. Calculate the elastic potential energy of the spring. Use the physics equation sheet. So I'm going to go to my physics equation and find the elastic potential energy one, which is 0.5 multiplied by the spring constant multiplied by extension squared. In questions like this, you get 3 marks. 1 mark is always for writing down the equation. The second mark is for working out, which includes substituting values. And the third mark is to write down the answer. But sometimes this is worth 4 marks if they don't give you the units. If they don't give you a unit on an energy question, just remember all energy is marked in joules, which is J. So I'm going to substitute my values. So we've got 0.5 multiplied by 40 newtons per meter multiplied by 80 millimeters squared. I am just going to check that the extension unit, what the units of extension are. If you have to convert it. Yeah, it's measured in meters. So, millimeters to meters. So 80 millimeters is obviously 0.08. So with that, we're going to do, with our calculator, we're going to do 0.5 times 40 times 0.08 squared. Can you see that? Yeah, like that. And we're going to press equals. That gives us it as a fraction. Then you press SD, and that gives us 0.128. And that is the answer for the first one. Well, not the first one, that one. The next question. Write down the equation which links extension, force, and spring constant. Effectively, it's always, you have to write it exactly how it says on the equation sheet. If it's on there, obviously. So it's extension, force, and spring constant equation. Why is the lighting so bad? What? Here we go. So it's With these questions, though, they will accept just doing F equals K times E. I'm just going to check the mark scheme to see what the equation they're looking for is. Yeah, so force equals. So, yeah, we got that bit right. Lovely. Next one. A force of 300 newtons. Wonder if this is very gloomy. Like, I don't know where to put it. A force of 300 newtons acts on a different spring. The force causes the spring to extend by 0.4 meters. Calculate the spring constant of the spring. So, going to make the triangle. So, SC for spring constant, E for extension, F for force. We're trying to work out the spring constant, so we're going to do force divided by extension equals, I'll just write K. So we've got 300 newtons divided by 0.40 meters, which equals 300 divided by 0.40 equals 750. And the units are given to you in this question. 750 newtons per meter. Next up, question 2. So we are going to check it with the mark scheme now. Okay, for question 1.1, the correct answer is the spring will return to its original length when the force is removed. So that one is correct. For the method question, it's this. So it says measure the original length of the spring and the extended length of the spring with the meter ruler. Extension equals extended length minus original length. So we've got that one. And 1.3, the correct answer is 0.128 joules because it's 0.5 times 40 times 0.08 squared because E equals 0.8 meters from 800 millimeters. So we've got that bit right. And this question behind here, the correct equation is force equals spring constant times extension, or F equals FE, KE, sorry. And question 1.5, if you substituted values, it would be 300 equals K times 0.40, which means K equals 300 divided by 0.40, which is K equals 750 Newton meters. So for the first section, we have 10 out of 10. Section 2, or question 2. Professional players, rugby players, wear a tracking device that measures their velocity and acceleration. Figure 2 shows a player wearing a tracking device. The player is tackling another player who is running with the ball. Tracking device. 2.1. Vector acceleration are both velocity and acceleration are both vector quantities. What is a vector quantity? A quantity with both magnitude and direction. B, a quantity with direction only. Or C, a vector with magnitude only. So, a vector in physics is a quantity that has both magnitude and direction. It's important not to get confused with a vector in mathematics, which is to do with graphs and movement of triangles, squares, parallelograms, whatever you're doing. It's important not to get confused. This and this is both scalar quantities. So it's that one. Next, which of the following is an example of a vector quantity? A, displacement, B, distance, C, time, or D, work done. Out of these four, displacement is the correct answer. What? What is the issue? What's wrong, Lucky? Why are you writing for? Next up, 2.3. Figure 3 shows a velocity time graph for the player running with the ball. Velocity in meters per second is up the y-axis, going from 0 to 4.5, going in 0.5 concurrence. And time in second along the x-axis is going from 0 to 4 in 0.5. For 2 marks, you need to determine the acceleration of the player between 0 and 1.6 seconds, which is where it stops. Yeah. So the velocity equals 4. And the time equals 1.6 seconds. And acceleration is velocity times time, I think. I hope. I actually forgot. What is it in the equation sheet? Hang on. Yeah. Acceleration is change in velocity divided by time taken. So which is 0 to 4.0. So it's 4.0 divided by 1.6. 4.0 divided by 1.6 is 35 over 4, or 8.75. So the acceleration is 8.575, wasn't it? 8.75. Oh, I'm knocking it. I always knock it. 75 meters per second. The next question, 2.4. Describe the motion of the player between 3.4 and 3.6. Well, 3.4 is there and 3.6 is there. So it goes from 4-second velocity to 0 in 0.2 seconds. Now, that means deceleration to a halt. Deceleration to a halt. 2.5. Write down the force exerted on the player when she is tackled causes her to accelerate. Write down the equation which links acceleration, mass, and resultant force, which would be resultant force equals mass times acceleration. Next, 2.6. The player accelerates at 25 meters per second squared when a resultant force of 1,800 newtons acts on her. I'm going to write down the triangle. So we've got AF. So trying to work out the mass, so we do force over M equals F over A, which is 1,800 newtons divided by 25 meters per second squared. So if we do that in the calculator, we get 72, meaning the mass is 72. 2.7. The tracking device sends data to a computer during the game. Suggest one advantage of data being sent during the game. Whoa, camera, no. I caught it. Let's not worry. Da, 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 da. Next, question 3. So we're going to check our answers with the mark scheme. Right, back to 2.1. The question was about a vector quantity. The correct answer was A. It's a quantity with magnitude and direction. 2.2. The correct answer was displacement for the 1 mark. This one we've actually gone wrong, so it's so acceleration was actually 2.5. So that one's wrong. And this one, it was constant deceleration. For 2.5, it's F equals M times A. And for the next one, it's 1,800 equals M times 25, which means you do 1,800 divided by 25 to get 72. And performance can be monitored during the game. Lovely. So that is 8 out of 10. Yes, 8 out of 10 for that question. Next up, we have our 4-mark question here. A student made water waves in a ripple tank, which is the required practical for that is the required practical for this part of physics. This is P13. It's just before you do the electromagnetic spectrum. And on combined science, this is the penultimate unit of physics you will do. 3.1 says, describe how the frequency and wavelength of the water waves in the ripple tank can be measured accurately. Okay. That's fine. So, how are we starting this question? Okay, so we're gonna... Okay. Next, the student recorded values for the frequency and the wavelength of waves in the ripple tank. Table 1 and Table 2 show the results. So, Table 1, reading 1, the frequency was 9.8 hertz and the wave was 1.7 centimeters. In reading 2, the frequency was 9.4 hertz and the wavelength was 2.2 centimeters. And reading 3, the frequency was 9.3 hertz and the wavelength was 2.1 centimeters. Now we need to determine the mean wave speed. So we're going to work out, first of all, wave speed equals, and I'm going to use my equation sheet here, and we're going to determine that wave speed is equal to frequency times wavelength, which means that we're going to work out the mean frequency by adding up 9.8 plus 9.4 plus 9.3, which gives us 28.5, and we're going to divide that by 3 to get mean frequency to be 9.5 Hz, and the mean wavelength equals 1.7 plus 2.2 plus 2.1 divided by 3, which equals 2 centimeters. So we do 9.5 hertz times 2 centimeters, which equals 19, meaning the mean wave speed is 19 meters per second. 3.3. What is the advantage of taking repeat readings and then calculating a mean? It means more accurate data produced. 3.4. The speed of the wave is affected by the depth of the water in the ripple tank. The deeper the water, the faster the wave. Explain how the depth of the water affects the wavelength of the wave if the frequency is constant. Deeper water means longer wavelength because V increases and F is constant. Remember, V is wavelength and F is frequency. Next, that's question 4, so we mark what we've done. 3.1, I will give us 4 marks out of 4. 3.2, the correct answer is, have I done something wrong? 0.19. Oh, because you got to change it into meters, of course you do. So that would be 0.02. So yeah, I'll take that. Is it 0.19? Yeah, we'll take that for 2 marks. Because if you make a mistake on the way, but you still show that you know what you're doing, you still get the mark. So I would still get some marks there. So I'll give myself 2. The correct answer for that one, reduce effect of random errors. I'll give that, but reduce random errors. And deeper water means longer wavelength. Got that one. So we got 2, 6, 7, 9 out of 11 because we dropped 2 marks there. Question 4. Here we go. Figure 4 shows the magnetic field around a pattern around a permanent magnet. Here it is. Where is the magnetic field of the magnet the strongest? I think So nearest to the poles, it will be the strongest. So like here and here. Next, how does figure 4 show that the strength of the magnetic field is not the same at all places? I don't know. How does it? The distance between field lines varies. Next, figure 5 shows an electromagnet being used to separate iron and steel from the non-magnetic metals. So we've got pieces of metal, electromagnet, and conveyor belt. 4.3. Explain one reason why an electromagnet is used instead of a permanent magnet. So, electromagnet is easy to demagnetize. Sorry, it didn't fit on the line there. Because it's 2 marks, we need to actually explain why. Like, we said the reason, but explain, yeah? Bring it a little bit closer, no problem. Let me know if it's still a little bit hard to read, yeah? It gets a little bit dark for some reason. I don't know why. Like, the light is a bit funny on this camera. Okay. We'll be back on this in just a second. I'm just finishing up something. Okay, so where were we? We're here. Electromagnet is easy to demagnetize, which means it's easy to remove separated metal. Okay. Oh, you can zoom it in. I'm going to do that. There you go. Next, 4.4. Pieces of iron and steel are attracted to the electromagnet. Name 2 other metals that were attracted to the electromagnet. Okay? So, the way we're going to do this, I'll just explain in a moment. Okay, so I would go with cobalt, and nickel for that one. Next, the design of the electromagnet cannot be changed. Give 2 ways the force exerted by the electromagnet on a piece of iron or steel could be increased. So, we can bring electromagnet closer to iron and steel pieces, or increase current in the coil of electromagnet. Okay. Next up, we have a little diagram here. Let me just move this. The conveyor belt that moves pieces of metal is driven by an electric motor. Figure 6 shows a simple electric motor. So we've got the North Pole magnet, South Pole, the magnets. Then we've got the battery, a wire, and then A and B. And a 5-mark question we have here. Let's put that. Here we go. The length of the wire AB in the magnetic field is 120 millimeters. There is a current of 4 amperes in the wire. The length of wire AB experiences a force of 0.3. Calculate the magnetic flux density between the magnets and give the unit. So I'm going to pull up the what's it called? The sheet that has everything on it, all the equations. And we're going to find the magnetic flux distance one, which is here we go. I'll just write it down. So we've got so that's the equation. Force on a conductor carrying currents equals magnetic flux density times current times length. So we're going to substitute our values. So we've got length of wire is 120 millimeters. The current is 4A. We'll just name that M for now. And the force is 0.36 N. Okay. So obviously we need to make that 0.120 times 4. Okay. So the first mark actually comes from changing 120 millimeters into meters, because of course length is always in meters in physics, which is 0.12. Just zoom that out a little. Oh, hello. The next thing we need to do is actually swap this round. So M equals 0.36 over 4.0 times 0.120. Okay, and that will give us the magnetic flux density. So 0.36 over 4.0 times 0.120 equals 0.75. And the unit is tons, okay? Or T. There we go. Okay, are we ready to move on? Or would you like me to stay there a little bit? Thanks for watching BTW Thirsty, by the way. Thank you very much. Hope you're enjoying this revision session. Okay, right, let's change it over, change the page. Okay, here we go. So this is Fleming's left-hand rule. Okay, Fleming's left-hand rule. So the finger thing. So the thumb is always the direction of the force, okay? That's always the force. This is the second finger, so that will be the current. And this finger is the first finger, so that's the magnetic field. Pretty self-explanatory. Remember, there is right-hand rule as well, so I'm just going to tick off the 5-mark question. Yep. I'm just marking it now. That's a full marker, actually. We got 15 out of 15 on that one. Lovely. Okay, question 5. Electromagnetic spectrum. Different parts of the electromagnetic spectrum are used in medical imaging. Figure 8 shows an image of a person's hand taken with an infrared camera. 5.1. Explain why the infrared camera is able to show that parts of the hand are at different temperatures. Also, for the last question of 4.7, you get a 1 mark for 1 or 2 correct. So it depends how close you are on the 2. So, okay, which basically just means that different temperatures emit different intensities of infrared, which are represented as different shades, okay? Because it's 2 marks, you've got to say the point, and then you've got to explain it. The actually do say if you can confuse, describe, and explain in the exam, it can have a devastating effect on your grade. So that it would give you the 2 marks. If you just wrote different temperatures emit different intensities of infrared, that would just be 1 mark for AO1. But which are represented as different shades is AO3. It would also allow wavelength, frequency, and amount for intensity throughout. If you were wondering, question 5 continues here. Okay. Infrared has a range of wavelength from 700 Newton meters to 1 millimeter. Which part of the electromagnetic spectrum would have waves with a wavelength of 6.5 times 10 to the negative 7 meters? So, I'm sorry for the issue there. I will move my hands from the screen then. Anyway, we've got the electromagnetic spectrum. I've forgotten where I was now. Hold on a minute. Right, hang on. So the electromagnetic spectrum is what we're using here, by the way. And it shows the wavelengths. Just let you know for when you're famous. Okay. So we've got RM, IV, UV, XG. Okay, so that's X-rays. Oh, we cut off a little bit. Hang on. gamma, UV, visible, infrared, micro, and radio. So 6.5 times 10 to the negative 7. Okay, that means that's 0.0000065 meters. Okay, which just technically means that's 650 Newton meters, which means it's just smaller than just bigger than infrared, sorry, which means it's visible light. That is the correct answer. Visible light. Visible light. Okay. Let's move on. The camera is so bad. Figure 9 shows X-rays and gamma rays being used for medical. This is an X-ray, and this is a gamma ray. To use X-rays for medical imaging, a machine produces a very brief burst of X-rays. To use gamma rays for medical imaging, a radioactive isotope is injected into the patient's blood. The isotope is circulated around the body in the blood. The isotope emits gamma rays. Compare the potential risk to a patient using X-rays and gamma rays for medical imaging. It's worth 4 marks, which means you need 4 points. So, an obvious one for me, it's both ionizing radiation, so some risk of cancer. Okay, that's the easy one. That's the easy top one, yeah. But also, it means the whole body is irradiated, or I can't ever say this word, irradiated by gamma rays, yeah. Or just invaded. I don't know if they'd let you write invaded, but that's all that word means. Also, when an X-ray is taken, only a part of the body is affected, but exposure time for gamma rays is longer. That's all you got right there. So 4 points, both ionizing radiation, so there's some risk of cancer. I put the whole, but the whole body is by gamma rays. When an X-ray is taken, only part of the body is affected, but exposure for gamma rays is longer. Next. X-rays are produced by colliding high-energy electrons into a metal target. The electrons have high energy because they are accelerated to high speeds. Only a small proportion of the kinetic energy of an electron is converted into an X-ray when it collides with the metal target. An electron is accelerated through a distance of 15 millimeters. The work done on the electron is 1.2 times 10 to the negative 30 joules. Calculate the force of the electron. So the equation is work done equals force times distance. So we've got 1.2 times 10 to the negative 13 joules equals F times, this is millimeters, so we convert it to meters, yeah? Which is F equals 1.2 times 10 to the negative 13 joules over 0.015 meters, yeah? Which equals 8.0 times 10 to the negative 12. And the unit's already given to you. And that is the answer for that one. That's 3 marks. So converting this would not give you a mark. So you write it down like that, substitute, and like that. You can write down the whole equation, substitute the value, and then substitute it. Or you can just write it as it's given to you, So it's given to you as work done equals force multiplied by distance. But you can just do it like this. This is on your physics equation sheet, which means that you don't get a mark for writing it down. You only get a mark for substituting values in. Next. The metal target is made from tungsten, yeah? Tungsten has the highest... Why is this falling? The highest melting point of any metal. Explain why using tungsten as the metal target enables the X-ray machine to be more powerful. So some of the energy of the electrons cause heat. Therefore, increasing the temperature allows more electrons to be collided per second than using any other metal. They also allow, so using tungsten it enables more energy per second to be transferred than using any other metal. For that third point. Right, question 6. Scientists are developing a hypersonic, aeroplane that will travel much faster than normal aeroplanes. An aeroplane accelerates from a low speed to a high speed with the engines at maximum power. Explain why the acceleration is not constant. So at max power, forward force of engines is constant. As it accelerates, air resistance increases. Resultant force equals force from engines minus air resistance. So therefore, resultant force decreases. And acceleration is directly proportional to resultant force. And that's what you need for the 4 marks. So at maximum power, the forward force of the engines is constant. As it accelerates, air resistance increases. And the resultant force is force from engines minus air resistance. Therefore, the resultant force decreases, which means acceleration also isn't constant because it's directly proportional to the resultant force. Next. This is it for the question, and this is worth 6 marks. Sometimes your 6 marker will be either a writing question where you've got to do like a method, but sometimes it is actually just this. If it's a 6 mark question like this, it means you need to use, unfortunately, you need to use, what do I mean? You need to use, it's difficult to explain, but you need to use 2 equations. The hypersonic aeroplanes will have jet engines and a rocket engine. The speed of aeroplanes can be measured on a uniform scale called the Mach scale. Mach 1 is 330 meters per second. The jet engines will accelerate the aeroplane to Mach 5.5. The rocket engine would accelerate the aeroplane from Mach 5.5 Mach 25.5 in 300 seconds. The average resultant force on the aeroplane when the rocket engine is used will be 630,000 newtons. Calculate the mass of the hypersonic aeroplane given your answers to two significant figures. So first, we do change in velocity equals 25 minus 5 times 330. Then we do A equals in brackets. So open bracket, then open bracket 25.5 times 330, close bracket, minus open bracket 5.5 times 330, close bracket, over 300, which means A equals 22 meters per second. And then with that, M equals 630,000 divide 22, which equals M equals 28636.36 kg, equals to two significant figures, remember, 29,000. So first, you've got to work out the change in velocity, which means that you've just got to do the Mach 20. So the change in velocity is 330 meters per second per Mach. So 1 Mach is 330 meters per second. And the jet engines accelerate the aeroplane to Mach 5.5. But you've also got Mach 25.5, which just means you do 25.5 minus 5.5 in brackets times by that 330 meters per second to work out how many meters per second it will be between Mach 5 and Mach 25.5. And then A, right? A is just my way of working out the resultant for, not the resultant for, sorry. Is my way of working out what the change in velocity divided by time is. And that, you just do 25.5 times 330 in brackets, minus 5.5 times 330 in brackets, and all of that in brackets divided by 300, which gives you A equals 22 meters per second. And then with that, to work out the mass, you do change in velocity, which you already got given for, sorry, which is 630,000 newtons divided by that 22 meters per second. That gives you 28,636.36 kg, but it asks for two significant figures, meaning you change it, well, not change it, round it to 29,000 kilograms as the mass. So that is physics paper 2 higher. On Wednesday, so 14th of February from about 6:15 p.m, maybe a little bit earlier, we are going to be going through Chemistry Paper 2 from 2021. Then on Friday, Chemistry Paper 2 from 2022. So 2021 on Wednesday, 2022 on Friday from 6:15 p.m. Thank you very much for watching. I am Josh W. Make sure to subscribe to my YouTube channel for combined science videos, along with study with me live streams where I just study in silence. In the future, if you want teaching ones, so where we go through it and I actually teach you the content, be sure to leave me a like and a comment. And I will see you around. I try to upload every single Saturday and Wednesday, but I have been slacking recently. Thank you very much for watching this live stream. I will see you in the next one. Thank you very much. Goodbye.